connector, it will search for the load balancer mapping with the node mapping, and inside that node, then there will be service mapping with the pod mapping. Okay, like that. Okay, I will show you an example, simple example. So let also, if you want to see the settings of the kubeproxy, you can use this. You'll get CM kubeproxy, this thing. Let me show you. So it will show you the settings of the kubeproxy pod. Okay, in this command. Now I'm going to run one pod. Okay, with the name Nginx. Okay. Now what I'm doing? Let me check the IP table rule now. Okay, are there any IP table rule? Okay, so currently there are no IP table rules. Okay, now what I'm going to do? I'm going to expose the pod using service. It means I'm just going to create a service. Do we have any idea about the service? Hello.
We have to enable the service, right? I don't know.
No. Service, in the case, service is like a okay. We are going to learn about it, but service is the entry point for our pods, because like we will be having 4 to 5 pods. Okay, and you cannot remember the name of each and every pod. So for that, what we can use, we can directly use the service name. So because now if I run like 5 pods, then there will be 5 pods. Okay, with the different names. Okay, so suppose I cannot remember the pod name because it is different each time. Okay, but in case of service, we remember the service name because it is only one and it will not change even if we delete a pod or create a pod. Okay, so in that case, we can use the service to access the pod. Okay, maybe we are going to explain that in the service section, but just remember that we are going to access the pod using service. Okay, it will be having the mapping of the pod. Okay, so if you see now, we don't have any service related to test pod. Okay, it is just by default, so it is a Kubernetes service. Okay.
But I'm not able to see any screen.
Let me stop and share it again. Yeah, can you see now?
Yes.
Yeah, so we have created a pod, okay, with the name test, and we don't have any service. Currently it is a just by default service which is created by Kubernetes. Okay, it is not our service. Now if you see the IP tables, okay, let me see, are there any IP tables? So currently there are no IP route for this pod. Okay, now let's create a service. Okay, now we have created a service. Let's check it. So if you see the service, we are given the service name as test. Okay, and the service has the cluster IP this. Okay, and it is mapped to this pod. Okay, means we are going to learn in the service section how we are going to map it. Okay, but now just focus on this. Like this service is used to map to this pod. Okay, and it is explored on this port 3000 port. Are you getting?
Yes.
Now let's check the IP table now. So can you see the rules now? The test. Hello.
Yes.
Yeah. So these we need IP table routes entries has been created by kubeproxy. Okay. So whenever you are creating a service, okay, it will create an entry in the IP table. Okay. And what is this use? It will use to route your it will give you info to which pod we are going to reach. Okay. Means like here, if you see what is the pod IP, let me create let's see the pod IP. Okay. So if you see here, this is the IP of the pod. Okay. So can you see it here? Same thing mentioned.
Yes.
Yeah. So it is directing our traffic from the service to the pod. And here we have the service IP. Okay, here we have mentioned it. Okay, so what happens? Suppose some pod wants to connect with the our this test pod. What it will do? It will just curl this service. Maybe I guess it is the confusing to name the service and the pod as the same. So wait a minute, I will delete everything. Yes. Okay. So can you see any rule now with the test, right? No, right? Because we have deleted the pod and service. Okay. Hello.
Yes, yes.
Hmm. So now I'm going to create a service. So I'm going to give the service name as the my service. Okay. Now click. Here we have to give the pod name. Here we have to give my service. Okay. Now let's see the rules. My service. Okay, so can you see the mapping now? What it is doing? So whenever we are trying to access this service, it is sending us to this destination. Okay.
Right.
So if you are from networking background, you may be familiar with the DNAT, okay, routing things. Okay, so it is just adding the route in the nodes. Okay, getting? Hello, 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 hello. Are you there? Hello. Hello.
Yes, yes, yes.
So I thought I lost it. Okay. So it will create a route on each and every node. Okay.
Okay. So it's just like a normal route, or it's just only IP address.
Yeah, it is a normal route. Like suppose if you want to access your pod, you cannot remember the pod name every time. Okay. So but the
Okay.
service name will be static. There will be only one service. Even if you have like 5 or 6 pods, you're going to have only one service. Okay.
Okay.
So what we are going to do, we are going to give the service name. Okay. And what it will do, it will send us to the pod.
Okay.
Okay.
So it will give automatically the same range of IP to the all the EC, all the nodes,
No,
correct?
no, not the same name of the IP. IP is just a different thing. IP is given by the CNI plugin. Okay. CNI we have learned like Flannel, Calico. These are the plugins which are used for networking. Service, Queue
It's just
proxy.
like a cluster name or something or what?
No, no, no. It is not a cluster name. So service is like a let me open something. So like suppose you have got something here and you want 5 replicas. Okay. So now we have 5 pods. Okay. Each will be having different IP, but it will be in the range of your we are defined inside our cluster okay, what control manager. Okay, we have learned that thing. If you see uh, cat etc kubernetes manifest kube API server. So these are the cluster IP ranges. Okay, these are the ranges for the service. Okay,
Okay.
and there are different ranges for the pod. There, that thing we are going to see when we are going to create a cluster. Okay, so now if you do get SVC, can you see this is the service IP? Okay, I'll write it down here. So this is the service IP. This service. Okay. Now, if I do kubectl, okay, I will show you and what is this service cluster IP range? Okay, so we here in the kube episode manifest we have defined the IP range for service, not for the pod. Okay, so because of this thing, we are getting the IP in this range, right? In the service cluster range. Okay, it's different thing. But let's move to the pod. What I am saying, suppose now we have created a deployment with 3 pods. Okay, 3 replicas. Now there are 3 pods. Okay, now suppose you want to access a service. Okay, like this is the let's call it a my app. Okay, so this is the my app and it has 3 replicas. Okay, and each has a different IP. Right now, suppose you want to access your application. How you're going to access it?
With the help of the service name, we can access, right?
Right. But if you don't have service,
then we IP address.
Yes, IP address of which this one, this IP.
Right.
Okay, this pod IP. But the problem is, like suppose now this pod dies. Okay, because of some reason it dies. Now it gets a different IP. Okay, so it is a difficult now to track each and every pod and their IPs. Okay.
Right.
Yeah. So in that case, and suppose the like there are 3 pods. Okay, and if you know IP of only one pod, all the traffic will go to only one pod. Okay, because we are sending all these things to only one pod. Okay, so and we are not sending any traffic to this one, right? So in this case, this pod are useless because we are not sending any traffic to here. So in that case, what we'll do, we'll use the service. Okay, and service will map the its IP to the this pod. So suppose now I want to access this application. Okay, it doesn't matter which pod I'm going to access because all are serving the same application, right? It doesn't matter even if you go to here, right? Hello. Hello. Hello.
Yeah, hello. Sorry, might be some network issues.
Okay, so it doesn't matter if you're any one of the pod because all things are having the same image. It means it is serving same application, right?
Right.
Oh, yeah. So what we'll do, we will just do curl or in pod we'll do curl my service, and then whatever the port here we have 3000, we'll use this one. So it will do the round robin. Round robin means it will first send this first request to here. Again we are requesting, then it will send the second request to here, and in third request it will send this to here. So it means there will be less load on each and every node. So requests are perfectly balanced. Okay, so in that is why we are using my service. Are you getting?
Yes.
Yeah. And how service knows? Okay, means how the request knows which pod to go because we have the queue proxy, and queue proxy will do IP table updation. Getting?
Yes, sir.
Really getting or just saying yes?
No, getting.
Let me give you one more example. This time. This time I'll show you the real example. He was going to show this thing in the deployment section, but this, but so can you see this now? The application, the pod. This pod has the some random name. Okay, so we cannot remember the pod name.
Okay.
Okay. Now I will do one more thing also. Hmm. Now, if you see, okay, pod, oh, why? Okay, so if you see, we have these three pods. Okay, we are three applications, three replicas running of the same pod. Okay, or same application. Okay, and can you see the IPs here? Pod IPs.
Yes, yes.
Okay. Now suppose this pod died because of some reason. Okay. Let's see the IP again. So can you see there is a new pod has been created. Okay. Earlier there was 687. Okay. Now it's 698. Okay. So it means the IPs, suppose some pod died and recreated. In that case, their IP will be changing. Okay. So because we cannot track this IP as a human, we cannot store it thing. Okay. Because we don't know at what time the pod is going to die and it is going to get a new IP. Okay. So because of that, what we are doing, we are creating a service. So if you see the service, it has only this name. Okay. And so it will be easier to us to just use this service to instead of using these IPs. Getting? Hello?
Yes, yes.
Yeah. Means actually getting means why we are using service.
Yes, yes, yes.
And if you describe the service, the app one service, you can see the endpoints. And what are these endpoints? These endpoints are the IPs of these pods. Okay, get Miss, you are saying what is mapping? So it is just a mapping the service name to this IPs. Okay, the pod IPs, because it is easier for us to just use service name instead of using the pod IPs.
Okay.
Clear? Clear now?
Clear, clear.
Same app one service. Okay, so if you see here, it created a IP table entries for each and every pod. Okay, 896 689. Okay, you can see. Now suppose I'm deleting one pod. Let's see this entry now. I'm deleting this pod. It will automatically reflect. Okay, just remember currently it is 689. Okay, now let's see. What is it? 6 9 10. Okay, so who is doing this? Hello?
Sir, service, right?
No, it is not done by service. It is done by kubeproxy. You're currently working on service. It is just to map it. Means for in the Kubernetes end, it is just a mapping the service with the pod IPs. Okay, but in the routing level, it is done by kubeproxy.
Right, right.
Okay, just remember the purpose of the kubeproxy. We are currently focusing on the kubeproxy component. And what is focus? What it does it updates the hello.
Hello. It's a
What does kubeproxy do?
proxy. It updates the bot name and service identification, correct?
Yeah, it updates the IP table which contains the mapping of the service and the pod. Okay.
Yes.
You're getting or no?
Yes, I'm getting.
Okay, so this is about the kubeproxy. Okay, so and the next thing is container runtime interface. So first let's give me some overview about architecture, Kubernetes architecture. Just explain me everything.
Okay. Do I need to explain?
Yes, please explain.
Okay. So about the Kubernetes architecture, what I have till the time which we what we have learned is about the API. API is
Yeah, first start with the three components.
there are three components is available in the Kubernetes architecture. One is master node, worker node, and etcd. Okay.
Right.
And but sometimes etcd is also a part of the master node.
Right.
Correct. And
Yes,
now
correct.
if you come to the master node, we have three components are available on the master node: scheduler, API server, and the control managers. Correct. The API server responsibility are to provide to the all the instruction to the all the nodes or something, whatever we are happening, gathering the informations, and it contain all the data. Correct, all the informations.
No, API server doesn't contain the information
About the current state and everything, correct?
Yeah, it is stored in the etcd current
etcd
state.
is a configuration, it is stored in configuration, correct?
Yeah, it is storing configuration and current state. API server, what it does, it will just get the request and do all these things, updation, scaling application up and down,
Correct.
schedule the application means.
Mhm.
I also forgot. Yeah, so main focus is it is an entry point of our cluster. Okay, so it will do check the manifest, do authorization, will send, will do all the, like it will trigger other APIs. Like if you want to schedule some pod on some node, it will go through the API server. It will schedule the respective component. Okay, or delegate the responsibility to the respective container. That is the use of the API server. Okay, what about the scheduler?
Scheduler, work of the scheduler are used to schedule the pod.
Yes, pod on.
Worker nodes.
Okay, and what about the creation? Who creates the pod?
Controller managers.
No, I'm saying who creates the pod on the node?
Oh, okay, kubelet.
Yes, yeah, right. And what is user control manager?
Control manager or control the all the worker nodes like state and everything. Like if it
Right, yeah. It will just check if the application is the current state is in desired state. Like suppose if you mention something in manifest that should be replicated in our current cluster. So current state should be same as the desired state. Desired state meaning whatever we are defining in the manifest. Okay.
and kubeproxy, which we have just recently just checked, it's contain the IP tables, IP route.
No, it doesn't contain the IP table. It modifies the IP table of the node. Okay.
Okay. And also it's responsible to communicate with the all the available containers in the particular clusters, right?
No.
And internet as well.
So kubeproxy, it will just update the tables. Okay. Whatever the mapping is there, like service to the pod mapping will be in that IP table. Okay. And the load balancing, like suppose if there is a request is coming, it will be go through the service. Okay. And service will do load balancing. Load balancing means instead of sending traffic only to one pod, we are sending traffic to the all three pods. Like suppose there are 5 requests, first request will go to the first pod, second will go to second pod. So instead of giving lot of load on to one particular pod, we are sending it to the all the pods. Okay, those are different part. Just remember what kubeproxy does. It updates the IP table. Hello.
Update the IP tables only, right?
Yes. Kubeproxy is a network proxy and load balancer that runs on each node. So this thing is running on each node. And what is primary function? primary function is to manage the network connectivity between the different pods and service within. Means connectivity between the different pods and the service. Because we have seen it in the here. What it is doing, service is mapped to the pod IP. Service is mapped to the pod IP. Okay, so it is just doing connectivity between the service and the pod. Okay. That's it. Means we just have to learn about only 2 points of the each and every components. Okay, what the API server do? It will do authorization and admission controller. It will all the requests will go to the API server. What scheduler do? Scheduler will schedule the pod on the node according to the memory uses, requested CPU labels, all those things. Using all those things, it will schedule the pod on the node. Okay. Next one is the kubelet. Kubelet will create a pod, delete a pod, all those things will be done by the kubelet. Okay, and control manager will just check the desired state is the same as the current state. Got it, no?
Got it.
Yeah. I know it is too much theory, but I just want you to be good in the architecture. Okay.
Yes.
Because it will be help you in the debugging part. Okay, so now all these things are over. Let's move toward the CRI, container runtime interface. Okay, so what is the container runtime interface? To run a container, we need something. Okay, but there are currently different things are available on the market. Like suppose now we have Docker. Maybe someone try to create a different thing. Okay, like CRI CTL. Okay, but it will be difficult for anybody to adopt to new system. Why? Like suppose we are using Docker. Okay, and we are writing a Docker files. We are doing we are writing configuration related to networking. Okay, for the container. Okay, so all these things we are doing. Okay, writing Docker file, writing a container networking part, all those things. But now, let's suppose in future somebody new concepts and he writes its own new plugins. Okay, like called CRI, something like that. It is created. But now this time the difference is like it is more efficient. But now all these things, whatever we have written, like in the Docker file, the images we have created, the configuration we have written for the volume, networking, all those things will be useless if this thing is totally different from the Docker. Okay, so to avoid this issue, what we have done means not us, but the Cloud Native Foundation, he has designed some interface. Okay, so that interface depend all the rules needs to be followed if you want to create a new container runtime. Okay, like Docker or CRI means uh, what I'm saying, like suppose there is a road, and you want to drive a different cars. Okay, like if you have cycle, if you have like bike, something like that. And now if your bike size is bigger than the road, it will be difficult to travel on the road, right? Hello.
Right. I was speaking on mute. Right.
Okay, because we should follow something common standard. Okay, like suppose this is road, and now we are creating two cars. One is Tesla. I don't remember the spelling of Tesla.
Yeah,
Okay.
now correct.
And second is like Hyundai. Okay. Now suppose this is like a Docker. Okay, suppose this is a Docker, and second is the Hyundai.
Okay.
Okay, and for our simplicity, let's suppose all those things are running on petrol. Okay, all these things. So suppose now I'm designing some engine. Okay, diesel engine. Both are having diesel engine. So we should make it compatible. Like it will only take the diesel. Okay, because we have system set up for the diesel, means processing of the diesel, to export the diesel. We have all the system. Okay, to fuel our bike. Okay, but now suppose Like in future, I created new car called okay, this is new brand, and now it is running on what we'll say banana. Okay, but we don't have any setup for banana, right? Because it is not few, it is new thing, right?
Right.
So because of that, what we have done, we have set up some prototype. Okay, to design it, to create a bike, we need an engine which will run on the diesel. Okay, same thing like that. We have the some set of rules for the container runtime, like Docker, Kubelet, sorry, not Kubelet, Docker, CRIO, and container D. So these are the different container runtimes. Okay, which can be used to create a container from image. But we have designed some set of rules which needs to be followed by this particular container runtimes. Okay.
Right.
Means what is the CRI? CRI is just a set of rules which needs to be followed by our container runtimes to create the plugins or the software. Okay. So what does CRI do? CRI will specify the standard set of operations that container runtime should support in order to integrate with the Kubernetes. Okay. Also, it is responsible for managing the container life cycle, like starting, stopping, restarting. All those things has been defined in the CRI, and that needs to be followed by all the CRI implementation like Docker, CRI, Container D. Okay, so it needs to provide this thing like starting of all this APIs to create doc, delete and stop container. Because like suppose now in Docker we have command to stop the container. Okay, we have that feature to stop a container, but in the container D we don't have that feature. Okay, in that case it is very difficult to kill the container. Okay, we have to write some another script to just kill the container. So because of that, they have defined some standard for a container runtime. Okay, to create a new container runtime. Got it now?
Got it. But it is just behave like a middleware or where? So this we have to install on the cluster or Docker image.
No, so it is not a Docker image. It is a actually used to create a container. Means it will use the images. It will actually use the image to run. Okay, like
so where we have this CRI in the cluster, Kubernetes or Docker.
yes, we have to install this on the every node because it is component of the worker node. And as you studied, we have to install all the components of the worker node on each and every node.
Okay.
And what is use? Its use is to create a container, stop a container, build a container.
Okay.
Launch.
So when we are using EKS, so it automatically installed by the AWS or we have to install it.
Yes, it is automatically installed by AWS. Whatever I am currently teaching now, all these things, architecture, everything is done by EKS. We don't have to do install anything else. Okay, we don't have to install control manager, kubelet, anything else. No, everything is managed by EKS. Okay, kubelet, kubeproxy, this thing, everything is controlled by EKS. Okay, but earlier there was only Docker. Okay, it was very popular, but now in the new things they are using container D. Okay, let me show you. Currently I'm here. Let's see status of the Docker. Okay, now it is Docker also running. Now see container D. So actually Docker internally uses the container D. So it is installed. Okay. Now SSH. Okay, so we are currently seeing Docker, and if you see here, there is a container D. Okay, so Docker internally uses the container D. Okay, and now Kubernetes has removed support for the Docker. Why? Because it is an extra step. It is kind of middleware between the container D and Kubernetes. Now Kubernetes don't want that. Okay, so it has removed this Docker. Now only means if you see, Here you can see they have released this. Kubernetes support Docker via Docker ship is now removed. Okay. And it is, they are saying it is not a
I am getting one call, so can
okay.
close this some official calls. So can we close here the training?
Okay.
And I can
Okay. We'll connect tomorrow in the
sure.
morning.
Sure.
Morning.